Well, we will move into a little bit of background on the Energy District movement. So the Clayton County Energy District is part of a larger network called the Clean Energy Districts of Iowa, and it's based on a universal local approach. And what that means is the Clean Energy District network kind of provides overall support and resources for individual energy districts, but we all operate based on our local needs and our local circumstances. So you can see here all of the different energy districts. We have 13 now in the state of Iowa and then one up in Wisconsin. Um, and a clean energy district is a local institution created to strengthen communities by leading, implementing, and accelerating the locally owned clean energy transition. So specifically here in Clayton County, our mission is we are a nonprofit organization committed to strengthening our community through inclusively leading, accelerating, and implementing the clean energy transition. We were the second energy district implemented in the state of Iowa after the first one in Winneshiek County. These are just some kind of core tenets of our mission. We really focus on affecting the local economy by retaining and reinvesting our energy dollars, really focusing on that local ownership. We also want to positively impact the climate by promoting wise energy use through renewable energy and energy efficiency. And we also really want to promote equal access. We believe that locally owned energy should be inclusive and available to everyone. This is our overall vision. We're looking for 100% local renewable energy by 2050. And the reason that we do this work is due to energy drain and energy burden. So here in Clayton County, we have just around half of households that are energy burden. And energy burden is the percentage of your income that you spend on energy. And 6% is considered high. So again, just around half of our households here in Clayton County have that 6% or more of their income spent on energy bills. A lot of that here is kind of due to our landscape. There's some communities that don't have access to the natural gas grid and might rely on more expensive forms of electricity. And so to kind of wrap this all together, we believe that paying less for energy strengthens our community by making sure that residents have more for their own bottom line. And we call this green meets green, the green of energy prosperity meeting the green of strengthening our local economy. All right. So we also have a contractor network here at the Energy District, and our panelists today are both members of that network. These are local installers who support our mission and are installing various types of renewable energy systems in the area. And with that, I will kind of start our panel here. Again, we have Dean and Doug with Northeast Iowa Mechanical, and then Larry and Keegan with GeoEco Options. So how do geothermal energy systems work? And I'm going to hand this one to Larry and Keegan.
Geothermal for residential, commercial, both run on the concept that we're simply transferring energy. We're not creating it. So we use the constant temperature of the ground to install a loop system that transfers fluid from the equipment inside the building and uses that constant temperature of the ground to either reject heat into the ground in the summertime by removing it from the structure, or it will pull BTU energy from the ground and bring it to the facility in the wintertime. So you're using that consistent temperature of the ground rather than depending on an environment that we enjoy in this area where it could be 100 degrees in the summer or minus 20 in the winter.
Awesome. Thanks, Larry. And we'll get to our second question. So what types of systems are most common here in Northeast Iowa? And Dean and Doug, I'll let you guys start with this and kind of specifically thinking about the waterless system that you guys are working on recently.
Can you hear us?
Yep.
Okay, so that picture there is from the pit at Jim and Jolene Jansen's, who were putting the waterless system in. So what types are most common? I would say waterless is not the most common. That's just something we started doing in recent years. Put a few systems in, more in the, still in the experimenting phase as to how they perform, how much they cost to install, how much they cost to operate, all that kind of thing. But I would say there's more systems out there by far in the more traditional way, such as what Geo Inc. would install with PPE or polyethylene. I hope I'm pronouncing that right. Larry, you can clue me in, but pipe in the ground that has a water antifreeze mixture going through it. Um, but in either case, both systems have a loop in the ground. One has plastic pipe for a simplified version of explaining it, and the other one has copper pipe. The waterless systems do not have water antifreeze, they use refrigerant. So the generic term for waterless is direct exchange, where the refrigeration system in the indoor unit is exchanging the BTUs directly to and from the ground through the refrigerant instead of going through a water solution first. Um, I would say we've got I don't know how many systems of the waterless out there, probably more of the systems that use water than the ones that use waterless. That would be waterless. But we've got some data from a few of both kinds of systems as far as cost of operation and that kind of a thing. Um, and I would say they're both comparable as far as that goes. Um, the waterless systems you can only install in a horizontal application. You cannot go vertical in Iowa. So, if we're in towns and places like that where space is limited, that's not going to be an option for you. Um, and I would say they're in general a little bit more money to install than a system that would use a water antifreeze mixture through plastic pipe. Um,
I would add to that. I like the thought that you've got, uh, Dean, where you guys are designing systems based upon the location and the ground type. And I would say the most common system in Iowa is based upon the design of where do you live, what is the structure, and those are the types of services that you're going to have performed by an educated and trained installer. That's where the inside equipment is designed to meet the needs. And then in Northeast Iowa, we see everything from vertical drilling, as was mentioned. That's propylene glycol. Because of our karst region, we do protect groundwater, and we want to make sure that anything that goes into the ground uh, doesn't affect our ability to stay clean and have safe drinking water. We see directional boring is another type of system that's pretty common in our area. If there's clay or the geology on top affords the ability to do directional boring, if it's clay, dirt, and that type of geology, directional boring is pretty quick. It's efficient and typically less cost per foot to drill. We also have opportunities for what they call slinky systems. That's where you excavate trenches and can place the piping in the ground by hand. And we also have done pond systems that also maintains the temperature that would work for the BTU transfer. So in Northeast Iowa, we see those types of systems depending on where you live and what type of ground you're sitting on.
and just for the those listening in from like the hospital and the school system in Guttenberg, a waterless system is not going to be an option for large facilities like that. It's more of a residential application. Um, so any other questions for Larry or us on the systems that are available, how they get installed?
Hey, Dean. Um,
Yep.
I do have, this is Jolene. I do have one question just on the waterless systems. And obviously right now the vertical installations are not an option because of state of Iowa, what the state of Iowa regs will not allow that kind of to have the refrigerant be circulating deep into the ground, as opposed to like what our system there was, like the lateral. And we have ground. We're a rural resident, so right now there are options for rural residents. But what I was wondering is if the state of Iowa would ever change some of their groundwater protections or allow something like that. Would this be an option for communities where businesses that are, obviously limited in square footage or whatever, and where you could do where your lot size limited, but the allowance was there, like in other states where they do allow this. There are quite a few states that do allow the vertical. Is that something that would eventually be something to consider as far as technology?
Yeah, potentially. I mean, like for an office building that doesn't have a ton of square footage, but has enough space, in the backyard or whatever to put a vertical system in, then it would be potentially an option. Um, Larry would probably know better than I would as far as distance from lot lines and that kind of thing that any kind of a loop can get put in, whether it's waterless or the more traditional propylene glycol methods. But the whole thing that caught my attention with waterless in general was because um, the size of the borehole and the depth of the borehole are smaller. So for areas in towns like we have Volga and Claremont and Elgin, where there's a lot of propane, where it's all propane, and you can't sometimes get a big drilling rig in the backyard to put a geosystem in. Potentially, a person could buy a small track type drilling rig to be able to put in a waterless um, geo loop. But again, it'd have to be in a vertical application, which is not permitted at this time. So, so yeah, there's definitely potential out there for the waterless. Um, Again, that was the main thing that caught my attention is I mean, we live in Elgin with a lot of propane. I was just trying to think of different ways to be able to get geothermal in, but I haven't spent a lot of time looking at distance from lot lines and all that kind of thing. And every town's going to have a little bit different rules on that too.
I think to add to that, I see many of the small towns are uh, burdened by needing the propane tank and are not having an option for other heating sources. And that's where you look at things like green space, there's central parks, other places where you can put in ground exchange systems that would, once installed and buried, could still be used for a park facility, for playground, for whatever, and that can be enjoyed even in a bigger facility for parking spaces. Once the vertical loops are in, you can utilize that space for parking. So there are some considerations for those governmental, nonprofit, and commercial avenues for geothermal moving forward, since the tax credit still applies to those considerations are worth exploring to see where communities might have some green space that can be utilized and even could be set up as like a utility so that if the city owned it, they could do something similar to what West Union's doing in having a central power plant buried in your property and supply that energy at so many dollars per ton to your customer.
Yeah, that was, I was going to bring that up, Larry. And I know Steve's on this call, but if you maybe, and I don't know, Kelsey, do you have a question later that goes to thermal energy networks? Because that's something that
Yeah,
would
I think we had a question at the end, just kind of some area applications to talk about, but we can
perfect.
certainly keep the conversation going too. And
Oh,
talk
okay.
about it now if that makes more sense.
Yeah, I just think that that might be a conversation that might be worth having here, as far as there are some the direct credits through the Inflation Reduction Act would apply to heat pumps that use those thermal energy networks. The only known application of a thermal energy network here in Northeast Iowa right now is over in West Union, and Larry happens to be they are the operator of that system. So if you would maybe just explain how that works in very broad strokes, Larry, that might be something that, again, these propane stranded, or yeah, those communities that are stranded from the natural gas grid would maybe be, even for posterity, just to have it documented in this conversation would be good.
The thermal energy network at West Union is under quite a bit of study right now. It was forward thinking in its design, probably a little misunderstood when it was originally uh, incorporated into that downtown design. What they've done is taken the courthouse square, and in the courthouse square, there are 132 vertical geothermal exchange units 300 feet deep. And each one of those provides, as an engineer's estimate, 2 tons of energy capacity. So in a short sense, they installed 264 tons of equipment or of loop in that area. And then throughout that project, they were able to replace street sidewalks and were able to connect uh, all of the piping out to the facilities and buildings around the central square. Once that's done, the fluid in this system is all set up in the courthouse basement, and the West Union District Energy LLC is responsible for tracking what buildings are hooked up, how many pieces of equipment are inside those buildings, and then just calculate a usage fee for the buildings to connect to that fluid exchange. And that way, it's a community asset. Each building doesn't have to drill technically their own loop. It's already installed. And then we just track system performance, determine what the load is on that loop, how much more we can expand and add to the loop before the system reaches its capacity. And at this current stage, it's performing extremely well and could be demonstrated to several organizations throughout the United States and actually in Europe as well that are studying the system. It's performing very well.
Yes, it is.
Awesome. Thanks for sharing that. We can kind of come back to that too at the end if there's more questions. So we'll go on here to question 3. And I'm going to ask Dean and Doug, what kind of equipment is required for installation? And I think here we're kind of specifically talking about inside the home.
Yeah, so inside the home, you'd have a box with a compressor in it, and they make different models that are made for forced air applications or to heat water in certain applications. And that box, if you will, would have interface with the ground loop as well as the inside load. There's nothing that will go outside as far as equipment. It's not like a typical furnace air conditioner situation where you have an air conditioner sitting outside and a furnace on the inside. It's all the heating and cooling all gets done from the inside cabinet. Um, so, positives about that are everything's inside, protected from the outside elements. I think if you do research on geothermal versus, traditional HVAC systems, they last longer. I think that's one of the contributing factors. But I would just say too, it just seems like from my experience, and we do service traditional systems as well, but it just seems like geothermal units are made with higher quality. I think they're made with the intention is to last minimum of 20 years, maybe 30 or more years. And if they're installed properly, sized properly, so you don't have too long of run times, all that kind of thing, it's not that uncommon to go out to somebody's house after 20 years and you're the first person's ever showed up to look at it. That's not recommended, but I'm just saying that happens where out of sight, out of mind, nobody has any service done on it until it finally quits working for some reason, and 20 years later, you're the first person who's ever had to look at it. So again, the key is installed properly, sized properly. They have less maintenance cost, and it's all just involved in that box, if you will, in the basement or mechanical room, wherever that ends up being.
All right. And then question 4 here, Larry, do you want to talk a little bit about how long the system components last? Dean kind of covered the inside, but maybe you can talk about the loop fields.
Certainly, the material that was used that Dean mentioned earlier is high density polyethylene, and the manufacturers that we get ours from Centennial Plastics. It's manufactured in the United States. The engineers will specify a certain product and then look for its duration. We're looking at like 50 years when we do commercial projects that they expect to cover. The producers of this material say it'll last 2 or 3 times longer than that. It is a very impervious material. It's actually the same material the gas companies switched over to. Like if you've seen utilities on either gas or the directional boring for fiber, you'll see some orange piping or you'll see yellow piping. It's all high density polyethylene. It's different colors for the purposes and the uses. But the loop system, kind of like Dean said, once that's in, there's really nothing that's going to wear on the loop. It's the mechanical stuff. It's the pumps and the things inside the house that are all the moving parts. What we have in the loop system should last 50 to 100 years.
All right.
Hey, Dean.
And then,
sorry, Kelsey, I'm going to just ask one quick question that's on that. As far as the loop fields that go into the waterless systems that are directionally bored, is there any concern with that, with the circulating refrigerant that, as opposed to the water that circulates in traditional geothermal loop fields?
Yeah, so the main concern that gets mentioned out there is how is the copper going to hold up? Will it corrode? Will it pit? Will it leak eventually? And there is certain ground conditions you have to be careful of not to put it in. For instance, you don't install it downhill of your septic leach field, for example, because that kind of soil will eat it up or has the potential to do so. So you have to be careful the type of ground you're putting it in. They do have anode rod protection that goes into the system, so it creates like a low voltage field, if you will, around the copper to protect it. And that anode system is hooked up to your unit. If that would fail, an alarm goes off. The company where we get the equipment from is out of Ohio, and they've been doing direct exchange for probably 50 years-ish, give or take, and have had very good results with it. I would say direct exchange in itself has been around for a long time, but a lot of the earlier designs, so forth, were not well thought out, didn't work well, didn't last. I would say this company is been with it for a long time and really knows what they're doing. So there are some additional things you have to consider when you're putting copper in the ground to make sure it's going to be a long-lasting system. But I would say it's maybe not as would be, because you have to be just more considerate than the plastic piping type loops.
Sure. There's also a question in the chat here. Can tree roots affect the loops?
I can speak to that from the high density polyethylene. it really doesn't. It's not going to be penetrated by tree roots. What we see more considerations of is making sure after you've had your system installed that you maintain good records or a good map or know where those connections are out in the field, because we bury everything below frost line when we do our connections, so it's maintained. What happens most of the time is people want to do an addition, or maybe they want to put more uh, trees or shrubbery in, and they're using someone to come in with a tree spade that injects into the ground, and then not knowing what depth or if you've changed any of the surface, it's more of a consideration for grabbing onto a tree and pulling it out with roots and everything that may have wrapped around the loops, but just normal growth of trees and shrubs and any other greenery is not going to penetrate the HDPE.
Thank you, Larry. All right. Next question for Dean and Doug. Can you retrofit systems to use existing building infrastructure like ductwork for a traditional system?
Yes, for sure. Yep. I would say that's probably the majority of what we do. We do new construction as well, but a lot of retrofit. One thing to consider there is, if you're sizing a geothermal system, you can be limited by the size of the ductwork unless you're going to upsize the ductwork in certain situations. But yes, you can definitely retrofit it.
And then Larry, I think we kind of covered this a little bit, but if you just want to talk a little bit about, is there any separate equipment that's required for heating and cooling?
In a residential system, everything takes place, connects, and comes into the building. In situations where maybe the hospital, where you're figuring out what may happen, there have been designs on commercial where they do what they call a buried vault, and vaults are where several connections are made of the loop field, and then just supply and return lines go into the building. There are vaults associated with the uh, district energy system in West Union, but there are less and less of those being designed in, even in commercial applications. So the overall answer is, for residential systems, really, there is no outdoor equipment that you'd have to consider.
And then Dean and Doug, do you want to just talk a little bit about how the systems are functionally comparable to like a traditional gas or electric source?
Um, I mean, I guess if you think of traditional gas or electric, a gas furnace would be burning gas, have an exhaust fan that's pulling that gas air mixture through a heat exchanger and then exhausting the remains out of pipe, either up a chimney or out the sidewall. And then as that heat exchanger heats up, eventually turns on a fan which blows across it, and that's how you heat your space. Electric would have just for lack of better words, like a toaster type element in the ductwork that would heat up and you'd blow air across. Um, Traditional cooling has a condenser that sits outside and has a compressor in the condenser that pumps the refrigerant through lines to a coil that's in your ductwork that either pulls heat out of the space to blow it outside in the summer through the means of that refrigerant circuit, or if you have an air source heat pump, you can blow air into your space from outside that's harvested from the air. Geothermal uses the energy, as Larry mentioned, in the ground and is able to transfer that energy. If it's heat, it's pulling it out of the ground in the winter and then through a coax exchanger, which is where your glycol water exchanges with the refrigerant, and then there's a coil in the box in the space that then blows across to release the BTUs into the building. So as far as how do systems function compared to traditional gas furnaces, I would say they both function well. Just the main thing that people go to geothermal for is energy savings reducing carbon footprint, longevity, things like that.
One thing I might add, and Dean, I might need your assistance with this. Uh, one of the comments we hear back from is getting used to the performance from a gas furnace is going to produce a higher, more temporary heat coming through the ductwork. So you might feel warmer air coming out of the ductwork at 120, 130 degrees, whereas a geothermal system is going to bring you 100-degree heat, 95 to 100-degree heat, and circulate the air more. So people talk about when they stand over top of the floor vent and they feel the air, that it doesn't feel quite as warm as what they were used to with the gas. But when you think it through, if the air coming out of the vent is 100 degrees, do you want it to be 100 degrees in your house? It's still heating the house and doing it constantly and efficiently. But that was one of the comments we got back, is compared to a traditional gas unit, the delivery of the air is the important to note, that it's not as hot coming out of the ductwork as they're used to with conventional.
Yeah. Yeah, that's for sure accurate. I would say like on the direct exchange waterless, we have gotten a little bit better performance that way. It's just not cut out for big commercial spaces.
Sure. I have another question in the chat here too. Jim asks, can you use geothermal to heat water for an existing radiator heating system?
You can, but you can only get a certain temperature out of it, like 120. I think we saw a water furnace brand. They have one that will put out a little bit hotter than that, but you're limited as to how hot you can heat that water. So if the system, if you're retrofitting something and the system was designed for a boiler that needed to be at 160 or 180 degree temperatures to really heat the building, then it's not going to work without adding more radiators to get the BTUs you need into the space.
Sure. Thank you. All right. And then our next question, how reliable are geothermal energy systems? Dean and Doug, if you want to kind of take this one, and then Larry, if you had anything to add.
Yeah, I think we've talked about this a fair amount already, but they're going to last half again as much, if not twice as long as the traditional systems, what we've seen. Again, if they're properly installed and maintained. So I would say very reliable.
Sure.
I don't know
And
if we have
just,
enough to say.
the ability to run on electricity, like have you seen any systems that have been paired with like a battery that would allow them to operate, even if the grid was down or electricity generation was cut off for some reason?
Yeah, there's a couple systems we've been involved in that have solar with battery backup, and can operate that way. That's not real common just because of the upfront cost of getting that all installed sometimes turns people away. But again, if you have in a commercial application, you have all the tax credits and so forth available, which we haven't gotten to yet. That makes it all more doable. So, yeah, I mean, if you're operating a geothermal system, it's going to take more electrical energy than a gas furnace, but it'll take less than an electric furnace. So if you're looking to retrofit from a traditional system to geothermal, and then when I add solar down the road or at the same time, that's all very doable.
From the loop standpoint, reliability, it has fluid flowing through it, just like your radiator does in your vehicle. And that fluid has additives to protect the metallic components that it encounters. So I would say from the reliability standpoint, the piping itself, the high density polyethylene plastic will last you 100 years. But you do want to sample your fluid after 5 years, or just to see where those protective components are, and if it's still able to have the corrosion inhibitors and the pH balance, those types of levels to protect the equipment that are being flowed through inside the house.
Sure. All right, thank you. And Larry, do you want to talk a little bit about the efficiency of the geothermal systems versus like a traditional furnace?
That's a good slide you have up there. It's a difficult concept to understand when people talk about the old days when they had an 80% efficient gas furnace and they moved to a 95%. People were really excited. That meant for every dollar you put into that process, you were getting 95 cents back, and they thought that was a really good exchange. In the geothermal world, since the temperature is consistent below the ground, every unit of energy that you use to circulate the fluid and to either extract heat or reject heat brings back about 5 units of BTU energy to be utilized inside the house. That's 500% efficient. So therein lies the true efficiency and energy savings for a geothermal system. Is you're only using 1 unit of energy to operate the system, and it's bringing you back 5 units compared to a conventional where you're using 1 unit of energy and getting back 0.95.
Thank you. And then do you want to maybe kind of going off of that, talk a little bit about like what kind of savings or a typical payback period can be expected based on that high efficiency system?
From the geothermal standpoint, the energy reduction is going to calculate into a savings compared to a conventional system. Remember, when you talk about renewable technologies, geothermal goal was to reduce energy. That reduce before you produce was what we learned decades ago. And it does have a payback. When people talk about how long does it take to pay back, included would be incentives, credits, rebates, and those all apply to, well, how long is it going to take for this to pay back? If you think about installing a geothermal system and your energy consumption is less than before you put it in, it starts paying back from day one. That gets confused with people that are talking in the wind and solar arenas because those two products generate power. Geothermal does not generate, it reduces energy consumption in that respect. So it doesn't matter if it's being fed by the REC, by your solar, by wind, it's just going to use less energy to perform. We've seen typical calculations with the tax incentives that pay back in as early as 3 years, depending on the rebates that are involved and which energy provider that rebate can come from. We've seen ranges of $200 per ton up to $1,200 per ton that the electrical providers are willing to contribute so that you put in this energy saving technology.
Awesome. Well, that leads us well into kind of our next couple questions. We've been dancing around the tax credits a little bit during this conversation. So, Dean and Doug, do you just kind of want to give a brief overview of what incentives are out there right now at the federal level for these commercial projects?
So currently there's a 30% federal tax credit, and then and that excludes any ductwork. If there's any ductwork involved, say it's a new construction commercial building, the cost of the ductwork and the labor to install the ductwork is not part of that tax credit. That is not eligible for it. So it's a 30% credit, but then there's also a 10% domestic. There's a 10% domestic tax credit. So as long as it's sourced from the United States, which I would say the majority of geothermal systems are going to be, it gets an additional 10%. So it's basically it's a 40% tax credit. That's the biggest thing. And then there's accelerated depreciation. You can, instead of depreciating it out over multiple years, you can depreciate it quicker. That's probably I would say that those are probably the biggest incentives.
Gotcha. Yeah, and just for kind of clarification as well, that tax credit is also available in a direct pay. So if you are a non-taxable entity, you can also receive that 30% in a direct payment. That's something that the county building here in Alcater and a couple other entities in the county have been able to do through solar, but also available with geothermal.
Yeah, that's what I was going to add is on that commercial, nonprofit, governmental, those were all included in the continuation of the geothermal tax credit. Some of the projects that involve federal dollars will add an additional 10% in areas that use prevailing wage tables to incorporate enhanced labor dollars into the project. We've seen those in neighboring states, and it can increase the 10% you save sometimes doesn't pencil out to the overall cost of the project because of you adding that prevailing wage component. So,
Sure. Thank you. And Larry, I think you kind of covered this a little bit already, but if you just kind of want to go over a little bit more, like what kind of incentives are available from local utility companies in the Northeast Iowa area?
several of the uh, utility providers offer rebates depending on the independent owned, like Alliance and the My Energy. I'm sorry, the Mid American folks. They might do it per project. Like I think Alliant, you can get up to $1,200 for your geothermal project. Uh, Rural electric cooperatives, RECs, like out in McKee, uh, will have a rebate per ton, uh, up to $400 per ton, and it's rated also on the efficiency of the equipment that you install. So just need to check with your specific utility provider, but almost all of them do offer some type of a rebate or incentive. And some will even do a rate for the electric if they can direct meter, and maybe make an agreement for peak hours versus off peak hours for operation.
Thank you. And then I kind of wanted to give this question to both of our panelists. Have you noticed some benefits to kind of the rural workforce development or any other kind of economic benefits from an increase in geothermal in the area?
I can take that from the outdoor component. Everything we do is domestically beneficial, from the product we use, from the people, the equipment. Everything we do in the geothermal world is enhancing the local economy. We're using local labor. We're using um, local product sources to supply the materials. Geothermal is a great opportunity to use technical skilled labor, operators and drivers to install our systems. And for the technicians it takes to do the inside work, which is on top of that, I'll let Dean and Doug address that.
Yeah, I would say renewable projects in general, whether it's geothermal or solar, um, there's opportunity there because it's somewhat specialized to be able to provide better wages to the workforce. So if you can offer a better pay, it interests the youth. We're going to be looking at a pretty significant, I might be getting on a rabbit trail here, but pretty significant potential problem in years to come because of the decrease of young people getting into the trades. Um, we're already very busy with workloads, and when I go to continuing education classes, um, the vast majority are significantly, you know, older. I actually had an instructor ask the question, how many of you are 55 or older in a class I was in one time, and it was like over 75%. So I think geothermal, solar, those kinds of things, from my perspective, have piqued some interest in the young people, are helping them to get into this kind of thing. So I think green energy in general is something I've always been interested in. I like the concepts and how it works. And I think everything that we do does improve uh, the areas that we live in.
I can add the to that. Like Dean said, there are several opportunities for career choices with these industries, and it's fun to go into the schools and do a presentation. What we find is the teachers seem to be more curious about the specifics behind the renewable options, and that energy translates out into the students. And we've been doing some interactive partnerships with schools and NICC to hold awareness events where they can come and see the types of technologies we use and the types of careers that are available to help provide that option for local graduates that they can obtain a career in an industry the way where they may have felt it was more of a job, dead end job until they found something else down the road. And I can let Keegan add in on that.
I think the biggest thing that we've seen, especially with Northeast Iowa Mechanical and ourselves, we're smaller companies, and especially working in the green space and things like that, it allows, how do you say, to kind of create your own career path, right? We're more on the construction side of running drills, more mechanically inclined with construction. So we've seen a lot of kids that have taken more of a perspective of, oh, I can do more than just one thing, right? I'm not just the guy standing here hitting the levers or running the shovel. It's okay, I'm learning how to run a directional drill. I'm learning how to run a vertical drill. But in the same aspect, the next day you could be, oh, let's go see what's going wrong with this loop field. If there is any issues, you can kind of have a little bit of an HVAC technician background. We've seen a lot of acceptance and conversations behind just the flexibility of the renewable energy space and what kind of that career can kind of take individuals. So
Yeah, and kind of following up on that, like what kind of growth have you seen in geothermal in the area? I mean, is it something that you anticipate expanding even more, like more opportunity moving forward? Like what's that kind of look like over the last 10, 15 years?
I'd like to jump in on that if I could, and
Yeah.
I'll let Keegan finish up. What we see is an increased demand in our field that is viewed as getting your hands dirty. And we get calls to deliver our services to jobs from Green Bay, Milwaukee, Minneapolis, Chicago, Davenport, because those areas have a growth in geothermal and not enough people entering the industry to support that growth. And we have a very dedicated staff of individuals, experienced, and are full servicing the area that we're in. If we could attract more people, then we could help to answer the calls. But the ability for people to travel, be away from home overnight, and be willing to accept those challenges, even if it's worth more money, is becoming harder and harder to lure people to that aspect of the job.
I can just say Larry pretty much said what I was going to say. It's we find ourselves, having to say no to more work than yes. It's an exciting time right now for geothermal as an industry. Just need some individuals to kind of look at it in a little different realm and the overnight travel and things like that.
Sure. Thank you. And kind of our last question here, Larry, you talked a little bit about West Union earlier, and we can kind of expand on that if we have some extra time. But Dean and Doug, I wanted to ask if you had a recent example that you wanted to share, an installation that you did in the area for a larger commercial client.
So I would like to share a couple examples. First and foremost, since we have people on the line from Northeast, I'm a Guttenberg resident, born and raised, used to small communities. I have worked in Des Moines. We have a wide array of customers, and I currently live in Decorah. Our shop is in Cresco, and those two cities have a little bit different viewpoints of how they're structured for careers and viewpoints for things like environment and technology. We did a project in Decorah for Alliant Energy. Alliant Energy just built a new operations center right at the intersection of Highway 9 and 52. And they did so at the same time when Decorah was trying to go through the steps of maybe putting forth their own utility program. So they wanted to become their own utility, and there was a lot of tension in the community on trying to get one entity to provide utilities versus the other. So in the midst of all of that discussion, Alliant Energy, who's in charge of selling electricity, puts up an operations center right in Decorah and installs vertical closed loop geothermal to heat and cool their facility and their shop. They've put new operation centers throughout Iowa and Wisconsin, and as they've done each one, they've incorporated geothermal into their administrative spaces, but not shop spaces. And in Decorah, they took the next step and said, let's see if we can't provide all of our needs with geothermal. And it just got under the radar attention. And you think of a company that could just open the windows in the wintertime and run the heat as long as they wanted to and charge their customers for the electrical consumption. They are putting cost conscious technology in their own operation centers with geo. And I just think it went under the radar. And no matter what stance you have on how that ended up in how to provide utilities, they've installed it and it's functioning very well for them. And that's a testament to, even if you can make your own energy, they're still doing the reduce before you produce and using geothermal in their own facilities. So they're kind of putting their money where their mouth is. And I thought that was an important one to share. Good Shepherd Church in Decorah, as a direct pay candidate, you might say, did extensive work on all green aspects. They've got solar, they've got ground source geo with directional boring. They were a participant and is a very good example. In your area, we've done a pond loop in the Claremont Elgin area that was designed for kind of a business and a home use that incorporates utilizing what's next door to you, as the pond was a good source for their energy. And we also have developments in like McGregor Marquette area where it's either vertical drilling, or if you have enough room, you can do slinkies. And we've done several slinky systems in residential areas for McGregor Marquette. So we have lots of different technology and lots of different systems right in the area of Clayton County.
Yeah, thanks, Larry. Looks like Jolene has a question.
Yeah, Larry, thank you very much for those examples. It's exciting, and it'll be great for further use for folks to consider that weren't able to join the call but wanted to be able to register for the event. We had a registrant mention that, and they weren't able to attend, that they inherited a geothermal system on a commercial building or shop building. and it was an instance of geothermal. I believe it's vertical. I'm not exactly sure, but the cost to operate and maintain the system has not been positive. And so do you have anything to say, and maybe Doug or Dean might also say that, just a little bit on those, just on that, and I'm sure maybe Doug and Dean have some other positive stories, but just at this point, would you respond to that just a little bit on systems that are just not performing like the way that you're projecting?
What we find is diagnostics is key. Specifically when people are used to a system in a conventional mindset, we have seen people inherit a geothermal system and use a setback thermostat to run the system. Geothermal is set and forget. You pick your temperature and you bring it to that temperature and it performs. When you ask a system like a geothermal system and you set it back to, let's say, 62 degrees at night and you want it to be 74 in the daytime, a geothermal system is going to listen to you and try to get you to that temperature. And in many cases, if it's asked to go more than 2 degrees at a time, will kick in backup or resistance heat. So you spend a lot of money firing up that toaster that Dean talked about earlier, and the geothermal system isn't even running. I often use the scenario that if you're driving down the road in the car and somebody says, it's really cold in here, could you turn up the heat? And I say, why don't you just roll up the window? It has a lot to do with how you're using the system and whether the facility you put it into is airtight, that you've done your blower door testing, your thermal imaging, your insulation values to see that you can't increase mileage on a car that gets 4 miles a gallon by simply painting the bumpers. You need to figure out how you're using it, how it's running, and we love to investigate those. So the best way to have someone become more comfortable with their system is to hear about them. And unfortunately, the 100 systems that do really well, people are kind of quiet about, but the systems that aren't performing sometimes get more airspace. We just like to be involved in that to see if there's maybe some way we can get a system operating that has been a challenge for an owner.
Sure. Thanks, Larry. Dean and Doug, do you have
Sorry, Kelsey.
anything to?
Oh, Kelsey, can I just interject on just what Larry said, just to reply? That was a really great response. And I think that same story goes forward to the story of the West Union geothermal loop system and what difference it made in just getting an operator in there that could look at the diagnostics. And I know Steve could probably attribute to that. But after this session, we'll do some follow-up, and hopefully Kelsey will make sure that we include some of that geothermal system over in West Union, their story, and the savings that has been benefited the users by just dialing in the system. Steve, I see you popped up there. Did you want to say something?
No, I heard West Union was mentioned, so I just popped up in case something was asked. Just trying to be prepared here. I'm going to share this with you from West Union. I'm going to say that everyone who is hooked into our system is very, very happy with this. First for economy, their businesses, so they're looking for that. But I will say we have one building in West Union, and Larry can talk about that too, that with the geo hookup, yes, it was a lot of factors went into it. The geo is functioning okay it's a 3-story building. And I believe, Larry, it's working well on the ground floor. It's also working okay on the 3rd floor. The 2nd floor is not. And part of that it was part of a urban renewal grant that went into this building. They had certain specifications on how heating had to go in, and it was not compatible with the geo system. It should have been, but they bypassed that. So everybody else is happy with it. It works great. And you're right, Larry, we've had people come in the library and they say, oh, this room is cold. Well, it's 70 degrees. And they forgot to bring their sweaters. And they go to the thermostat and jack up the heat and it goes nowhere, and it messes it messes everything up. There's a process you have to go through in manipulating those temperatures. So that being said,
And I think, Steve, you brought up a great point there. I think Dean would even know a little bit about that. The design of use for the building, the design of the building itself has a lot to do with the performance. And in that one of the instances, it was designed for like a commercial system driven by one central unit with smaller units spread throughout some apartments, and it was part of the design funding process that certain equipment needed to be used and a certain design had to be followed. Probably wouldn't have been recommended from the people that were putting it in, but it was unsuccessful in that design, and yet uh, we have 287 tons of capacity hooked up to that system, and uh, it's the fifth year in a row that the system users have voted for a decrease in their monthly fee because the system is performing so efficiently.
I'm gonna hop on that with Larry just to make a point here. We have a new building, or a building that's being renovated in our downtown, and Northeast Iowa Mechanical's doing the units that going in. They're going to install two 4-ton units, one for an upstairs apartment area and one for the main floor of it. So they're going to have 8-ton capacity. And if they were built today for their heating and air conditioning needs, they would be paying $64 a month. That's probably going to drop another. We're going to drop that again in the spring, I think. But you can't beat that for the cost. I guess that's.
Yeah. Yeah, thank you, Steve. Dean and Doug, did you want to add anything to that, or maybe share another example that you had in the area?
Yeah, I just wanted to speak a little bit to what Larry mentioned about the systems out there that are underperforming. And I'm sure Larry knows this better than anybody. When fuel prices go up, the demand for geothermal goes up as well. And so what I've noticed, say back in 2008, when propane, so forth, was really high, everybody and their brother was putting geothermal in. And not everybody understood how to put them in properly. And so we've been out to a few systems that were just way undersized, and the geothermal units working fine, doing everything it can, just has to rely too much on backup heat. So there are some of those kind of things out there. So as was mentioned, making sure that you have a proper handle on the load calculations. Not every retrofit building is out of the box, so to speak, set up for geothermal. You may need to add some installations, some better windows, different things like that first. Because it's all important in how the system operates from the very beginning, as well as how long it's going to last and the cost of operation. So yeah, I mean, we've been involved in a fair amount of the West Union units there. I think Steve maybe has some numbers that he gave to Doug as far as cost before and cost after, say at the library, for instance, and that's been improved significantly. They also have solar on the roof of the library. On a smaller, like more residential application, we did one a couple of years ago that the homeowner came in and was so excited to show us his bills and everything. And for the whole year, this was his heating and cooling and his hot water, electric hot water heater supplemented with the geothermal was only $706. And that was almost 4,000 square feet of living space. So it was ended up being about a 6.5 year payback. As far as over and above the cost of the system over and above a traditional system, to pay that back was about 6.5 years. Over the life of the system, they were probably going to save about $65,000 in cost of operation. over a traditional system. So geothermal has been around for a long time. And as Larry mentioned, as far as the airspace that Alliant building got into core, for some reason, the only time it seems to get a lot of attention is when people's pocketbooks feel it. But it's a good option all the time. It doesn't have to be only when tax credits are available. So I don't know. I guess we don't have a lot of experience in the big commercial applications other than West Union. I can't think of really any other. Yeah, I guess REC and Postville did a retrofit system here a couple years ago. They're also like the Alliant building. They're doing their administration offices as well as the whole parking lot, indoor parking lot for all their trucks. And they've been real happy with that. They also have a vault system in the ground, like Larry mentioned earlier, as far as the loop side is concerned. So I don't know. It's just we kind of feel like as contractors we have to do all the promotion for it. Most people don't think about it until we bring it up.
All right. Well, thank you so much, Larry and Keegan, and Dean and Doug, for all of the information that you shared. Really great. We might have some time for questions here at the end, or I'll make sure everybody else has your contact information as well. But really appreciate all the information you covered. And next, we're going to kind of go into another opportunity for funding. And I have SETI, the Clean Energy Districts of Iowa Technical Assistance Coach Steve Hopkins here to talk to us a little bit about Rural Energy for America program grants.
All right, thank you, Kelsey. I would just wanted to make sure people can hear me okay.
Yep. And did you have material you wanted to share, like a presentation, Steve?
I have a few slides
Sure.
that I can share. And so if that's okay, I'll go ahead and
ahead.
share my screen. I was debating whether to just talk or go with my screen, but I think I'll go ahead and do that. So. Okay, can you see my slide?
There it is.
Okay. All right. I'm only going to show about 3 or 4 slides, but in general, what I wanted to talk about primarily was the energy coaching that I do on behalf of Clean Energy Districts of Iowa, or SETI, and I think you're probably aware of SETI just from the conversation that's been happening. SETI is a consortium of the clean energy districts that have formed within the state of Iowa. And Kelsey, you're located right in the middle of one of them there with the Clayton Energy District, and it's a very active one as well. SETI applied for a grant from the USDA to provide what we call energy coaching. And what energy coaching is working with small business owners or farmers to help them decide whether to apply for a Rural Energy for America program grant, which is a USDA program. And if they decide to go ahead and apply, how to apply. And so I'm going to skip over a couple of slides, but provide you with a little bit of background about what the Rural Energy for America program is, or REAP is the acronym. And there are actually 2 programs that are within the state of Iowa that go by that acronym. There's a water quality state program called REAP. This is a federal REAP program based on energy. So I just wanted to make sure you understood the difference between the 2 REAPs. And what REAP does is it's a grant for small businesses and farms. And I'm giving you a little bit of historic information just to show that this program has been around for a long time. It was originally authorized by the 2002 Farm Bill. So we're in 2026 now, 26 or 24 years later. So it's been around during both Democratic and Republican administrations. It's administered by the USDA Rural Development Agency all across the country. And there were a couple of changes, and that's why I'm bringing up the 2022 information. And that is that the 2022 Inflation Reduction Act, or IRA, added additional funding to the original Farm Bill money that created REAP as a 50% grant. However, that changed in 2025, or went back to a 25% grant. So that's what we're currently in right now, is REAP as a 25% grant. What that means is it would, if awarded, a small business or a farmer would be reimbursed for 25% of an upgrade that's done by REAP. So I'll go ahead and get into the two main categories, and you can see where geothermal is up here. There are two types of grants. One is called the Renewable Energy Systems Grant, or RES. And there are different technologies that are included within that Renewable Energy Systems Grant. Solar is the most common in Iowa, but geothermal is in there under the RES system. Wind and biomass and several other technologies also are under this Renewable Energy Systems Grant. And in general, it's meant for technologies that are generating power in a certain way. And Larry, I think Larry Leliefeld had mentioned that geothermal actually is replacing energy. However, administratively, it still fits under this Renewable Energy Systems Grant for REAP. So if there is a small business or farm that's interested in geothermal as their particular project, it would fall under this category, the RES. The other one is the Energy Efficiency Improvement Grant, and that could include more energy efficient grain dryers or more energy efficient HVAC systems for a business, again, or lighting or cooling. In general, it's for the purpose of replacing energy inefficient equipment in a business. And I have this last statement highlighted because it does require an energy audit or an energy assessment as part of the grant application. And USDA requires that if it's an energy audit, which is for slightly larger type of projects, that the auditor has to have a CEM, which is a Certified Energy Manager certification. So there are stipulations about who can do an energy audit, and it's a requirement for those type of systems. It's not, however, a requirement for the renewable energy system. So in theory, a geothermal installation would not be required to have an energy audit. However, I'll say this, as an energy coach, I haven't yet had a customer apply for a geothermal grant. So if I were to have someone that wanted to go ahead and apply for one, I think I'd be in communication with USDA very closely to try to clarify how to put together this type of grant application for the Renewable Energy Systems Grant, because these technologies are so different from each other. And it would likely have some information about the energy efficiency gained compared to the inefficient system. So I just wanted to put that out there, that even though geothermal is eligible for the REAP grant, we haven't yet done one. And I'm looking forward to having that opportunity to be able to do that. And then at the bottom, I wanted to point out just a few of the ineligible project areas within the REAP grant itself. So the big one is that residences are not eligible for REAP. It is only for commercial businesses. This can be problematic on a farm where they only have one electric meter, for example, and we would have to differentiate between how much is commercial energy usage versus how much is residential use. Also, tractors and implements are not eligible, and there's a series of other types of pieces of projects that are not eligible. However, the main things that are eligible are either power generation or the energy efficiency components of projects. I'm going to show you our geographic area. So I had mentioned that I provide energy coaching, and I say I because my partner Mark Patton has in essence retired from his work at SETI, so it's just me doing energy coaching. So we're providing energy coaching services primarily in these counties, which are counties that have formed clean energy districts within the state of Iowa. My map does not include Des Moines County, which is what the newest energy district county down where Burlington is located in southeast Iowa. We have been given permission, however, from USDA to also do work in adjacent counties. So you can see that just based on our geographic area, northeast Iowa is our primary area that we're working, but we would be willing to work in, I think, any of these adjacent areas as well. And then just to show a couple of projects that have been completed, even though they're not geothermal. I've already mentioned we haven't done a geothermal project yet. This is a small project in Lansing, Iowa. Arliss Sewing Room, which is a small business in downtown Lansing, had a $2,200 grant just to install 2 air source heat pump mini splits. And they were installed last year. And I've been in contact with Arla a lot since they were installed. She's very happy with how they're providing much better heating for her 1,200 square foot business in downtown Lansing, as well as providing better air conditioning. Although, because of how her 1880s brick building is situated with glass facing the north, her primary interest was better heating in that space. And so it has reduced her costs quite a bit. So that's one particular small business. And then one, I know that solar might be considered the competition. However, this is a Clayton County example of Moiser Lumber in Guttenberg, which applied for and got a $16,000 grant, actually almost $17,000 for rooftop solar. And I think Jim Osterhaus, you might be in this particular meeting. This was a referral from Jim because John Finch, the owner of Moiser Lumber, was interested in this particular technology, and we worked with John to apply for, and he was awarded a REAP grant, and that was able to get hooked up and installed in 2025, and so that was estimated, including incentives, to have a 7-year payback and saving up to $1,600 a year. I'll be interested to talk with John about how, once he gets a year's worth of energy bills, what the actual payback was on it. But so far, he's been very pleased with how that particular project went. And so I'm going to stop right there and then just simply probably go back and get out of maybe I'll just leave it on the slide that shows the different types of technologies, because I can see you and I'd be happy to take any questions about REAP, but I did want to focus on these 2 different halves of the REAP grant and mention again that it's a 25% grant. It's a complicated grant to apply for. However, the applications that we've submitted have been awarded, our applicants have been very satisfied with the fact that they were able to achieve getting that 25 reimbursement for that particular project that they were interested in getting funded. We also had done several farm grain dryer energy efficient projects, and those have resulted in saving quite a bit of propane used primarily for grain drying. But again, it's not geothermal. Just to get back to the topic of this meeting, geothermal fits in this particular category. And we, as I said before, would be very interested in working with any small businesses or farms who may be interested in applying for a geothermal grant for this 25% grant. Another thing that I'll mention is that REAP is coming out with some new guidelines, and we're expecting the new guidelines to come out very shortly. As far as we know, those changes will not affect geothermal, but they will affect some of the solar applications where they're trying to restrict the amount of farmland that's converted to solar panels. And so the restrictions will be no more than 5 acres of farmland can be converted for solar panels. The language that we've seen will not affect geothermal installations, however. The other big one, which is related to restrictions on solar, is there's a lot of discussion in the new guidelines that will be coming out about not having components from foreign countries of concern, and they include China, Russia, North Korea. I think there are a couple of other countries as well. And as been mentioned in this particular meeting, our understanding is that most of the components for geothermal would not fall under that particular category of foreign countries of concern.
All right.
So I'll probably just stop there, and I'd be happy to talk, have some question and answer time period, Kelsey, if that's okay with you.
Yeah, thanks for giving that information, Steve. We are just a little bit past our end time, so if anyone wants to head out, I just kind of wanted to say a final thank you for attending. We'll make sure that everybody gets the recording of this meeting and any contact information if you have follow-up questions. But if you want to stick around and you have questions for any of our panelists, please feel free to come off mute and ask. Otherwise, thank you so much.
I have one question before you sign off, Kelsey.
Sure.
You're going to send us a copy of this, I understand.
Yep.
We do maintain a site with information about our geosystem and energy issues in West Union. Would it be allowable for us to make this whole presentation available on that website?
Jolene, what do you think?
Oh, absolutely. Yeah, Steve, we'll definitely, and I think I might be able to help you get it onto your website. So yeah.
We would contract with you to do that, obviously. But there's
No
good information in here and some things that somebody will ask me and I'll say, yeah, I don't know. But you covered all the bases with this presentation. And I think it'd be a valuable resource for somebody to click on and view.
Yeah. I think one thing that we talked about as follow-up material is just like a summary sheet on the actual incentives that are available to the various categories of potential users, our customers. So we'll definitely put a summary sheet out. Recording of this, we'll put a link to it. We'll put the site, this will go up on our Energy District YouTube page, and then we can add a link to greenupwestunion.com, no problem. So that's a great idea. And I might just real quick, Steve, while you're here, and just you went over the REAP opportunities, and I think this probably Steve, if you haven't already talked, I know that there are several applications of heat pump users in West Union in the thermal energy network that might really benefit from adding solar to power their heat pumps.
Yes.
And it was, from what I can understand, Steve, is the REAP grant would be available to those current geo users, that this would be an enhancement, and in so many ways. Now would be the time. So go for it, Steve.
Yes, that is true. For those that would be interested, they would be eligible to apply for a REAP solar application in that particular case. And so, yeah, that's a good point. I know that Steve Fate and I have talked about that with that particular possibility. So that is still out there.
Awesome. Thank you. And it looks like Jim has a question.
Yes, I think I know the answer to this, but the REAP grants would not apply to apartments above a commercial building, commercial.
No, unfortunately, they do not. Those residential spaces are not eligible, and that's an exception that drives me crazy, because there are so many downtown commercial businesses on the first floor that have apartments on the second and third floor. It's just that's the way the program is set up. It was set up as commercial space only and not residential.
And you can clarify for me, Steve, if you would. The RES does not apply for the geothermal because the loop field ownership the loop field is already in. So it would be more the electrification side that would apply to the geothermal heat pump. Is that correct?
Geothermal still falls under the renewable energy systems side of the grant.
Okay, this is Barb Collins from City of Monona. So I like your final point, Steve, on the thing. So we have a young couple that just bought one of our larger businesses in Monona. It was Sudrin Fabric, and it has indirectly 3 stories, but they have a 1983 boiler system they're looking at a emergency catalyst grant to help with things. And so I was intrigued about the solar on, because they have to put a whole new roof on and everything. And so I don't know if they could do geothermal, but since they have apartments that are not used right now, but they would like to get money, extra income through apartments, they can't go for the REAP grant then, since they have apartments that would be part of the building.
I've talked with them, so thanks for mentioning them. Yeah, they have signed up to work with me for energy coaching, and so that is true that the residential part of their building is not eligible for REAP. However, the commercial part is.
Oh, okay, awesome. That would save me a call to them, because I thought this might interest them. So thank you.
And Kelsey, if they were to consider geo in replacement of their boiler, then that business would also be eligible for the IRA. 30%, right?
Yeah, exactly. The geothermal for the Inflation Reduction Act tax credits will be continuing. So if they went with that, they could potentially get 30% tax credit on top of the 25% REAP grant.
So that confused me a little bit, because Monona put in geothermal at our community center 20 plus years ago. Very happy with it. And all that time we have only had 2 small issues. But so they're in a downtown, cement everywhere. We have grass between lot right next to there, and that's where we put our geothermal. How does that work for them? How do they put geothermal into a building that's downtown with cement everywhere?
Sure. Larry or Dean or Doug, do you want to talk about maybe other projects that have done that, or if it's even possible?
We see the constrictions in the downtown area many times. If there's dedicated parking or they have their own parking area, parking lots available, there are some new technologies that are installing within basement spaces that are coming out. Otherwise, centralized green spaces or some place that they could put the loops in and then install supply and return piping, maybe across the street or to a side space. That is a challenge for developed downtown buildings.
They do have their back is an alley, and they do have an area which they're going to redo to put 3 garage parking spots in for their apartments later on. So if they had to dig that up, is it worth having someone come look to see if they could put geothermal under there?
Sure, it would always be nice to look.
Okay.
Refer them on, and we can help them with options.
All right, thank you.
I have one last question for either Northeast Iowa Mechanical or Larry, or even maybe Steve Fate, just a little bit about North Fayette Valley, because I know we have some school superintendents here. And I know that North Fayette Valley is an example where they have a ton of solar being provided, and also they use a geothermal loop system for heating and cooling. Is anybody familiar with that system or how that's working for their school system?
Yeah, we did not get involved on the inside part of that, but Larry, you were involved with the loop side, right?
Yeah, we did the direction that the elementary school was a directional board system. We worked with Joe Griffith over there at the school. They were actually one of the first schools that were able to manage the paperwork aspect and receive the funding back from the program. So it was successful for them administratively, and it's performing for them pretty well.
All right. Do we have any final questions for panelists?
I had one quick story to share from a resident that put in geothermal last year. Pretty technical guy, likes to follow his energy use, and has his panel set up individually so he knows what circuits are drawing what energy. And typically in our industry, Dean, Doug, you can be testament. You usually hear about the challenges, but not the successes. And we got a call last winter, and it was the homeowner. He said, "I just had to share this with you," and he was laughing. And I said, "What's going on?" He goes, "Well, I'm tracking my geosystem right now, and I can pull it up on my computer. My geosystem right now is using 1,100 watts to heat the house, and my wife's doing her hair, and her hair dryer's taking 1,400 watts. So it was taking more energy for her to get ready in the bathroom than it was to heat the house." So he was pretty happy with that. Thought that was fun.
That is fun, Larry. And the Jansons would have a very similar story to tell.
Well, I'd like to say thank you for the opportunity to present, and would look forward to responding to any questions or challenges, and really focus on, if you hear someone that's struggling with, it's not performing the way we want. Sometimes it's quite simple. Like Doug and Dean talked about, we've worked with people that when equipment comes from the factory, there are certain switches, certain settings that make that unit perform the way it's supposed to, and simply cutting a wire or reconfiguring a thermostat solves the problem. If we could, have people feel comfortable about reaching out, we'd be happy to help.
Yeah, and I would say we do solar and geothermal, so I can say I'm not like partial to one or the other, but I do feel like geothermal is a better place to put your money. If you have the space to do it. Obviously, some of those downtown areas, it's gonna be more difficult. But one disadvantage I feel like we have in the geothermal industry is you can't see it when you drive around. But so you see solar panels everywhere.
Mm-hmm.
So solar kind of advertises itself, if you will. We have no idea when you're driving around who all has geothermal. But
I actually mentioned, you're very astute on that, Dean. I have actually mentioned to the West Union group that they should look at some marketing, put signs in the courthouse yard that says, buried beneath this sign is the equivalent of 400 solar panels of energy, because you don't see it, and it's very marketable. It's just something you can't see from the car window.
It's true.
because geothermal was a thing and made sense as for many years, and solar didn't really get going until all these incentives kicked in. So, but anyway.
Yeah, I appreciate you sharing that, and thank you guys so much for being here and being on the panel and providing your expertise to this topic. I think geothermal is a really exciting opportunity for us as an energy district to learn about a little bit more and promote a little bit more, especially as those incentives are continuing a little bit longer. And like you said, it really makes sense right now to go with geothermal. So we appreciate your time. Steve, thank you again for being here and telling us a little bit more about REAP. And I think with that, we'll wrap up, and thank you all for attending.